All right. So what did we call this? 1.10, because we actually skipped 9, and then it's modeling with functions. So we got the runway up here. So you got to put on some function high heels and come model for me. Oh. Alrighty. So when they're talking about modeling, it's usually kind of giving you those real life situations or scenarios and coming up with little equations for it or functions for it. So the first one we have has to do with we're going to try and figure out what is the better phone plan. So back in the day, like back when our book was actually published, it used to be when it came to like texting plans, because it was, when it was kind of new, because I think our book is from like 2005. You would actually go through and try to figure out like what's the best plan, because depending on the number of texts that you thought you would send was how you would base your plan off of. So if you didn't text a whole lot of people, you would pick the plan that only had 100 texts per month. Could you imagine only sending out 100 texts per month? And then if you thought that you were the really popular person and you would send out more than that, you'd pick a different plan. Well, then it became so popular, they kind of got rid of those plans, but, back in the day, so we're going to have a back in the day. So let's say we had a texting plan A. So for texting plan A, you had to pay a monthly fee of, let's say, $15. Okay. Plus 8 cents per text. And then they also had plan B that you could pick from. And on plan B, you still had that, you had a monthly fee, but instead of $15, it was only $3. Could you imagine a texting plan for $3 a month? That'd be sweet, wouldn't it? But of course, they're going to charge you for each text, and instead of 8 cents a text, they're going to charge you 12 cents per text. So we want to write a function that explains both of these situations, and then we want to figure out like what's the breaking point, like how many, like there's got to be a magic number, right? It's going to tell you which plan to pick from. So first thing we're going to do is we're going to start by writing a little function. So if we think of our plan A, and we'll just call plan A f of x. And we know that we have $15 per month, so regardless, we always have to pay that $15. But there's an additional fee, that's why it says plus, right? It even tells us put a plus there. Right? 3 cents per text. So it could be 1 text, 2 texts, 10 texts, or however. So the number of texts is going to be our variable. So we're just going to use x because we like x's, right? So it would be what? 0.08x, right? You guys good with that one? And then for plan B, instead of f of x, we'll just call it g of x, just so that we know the difference. Right? What do you think that function's going to be? Yeah. Right, yep, our monthly fee, plus our number, or our cost for our text, times how many ever texts that we sell, or use. So to figure out that breaking point, we want to know where these two are equal, right? And once we know where they're equal, then we can figure out which one we would choose depending on the number of texts. So we're just going to take both functions and we're going to set them equal to each other. So we would have 15 plus 0.08x equals 3 plus 0.12x. Right? And then we're just going to solve for x. So I guess I could subtract 3 from both sides. That'd give me, why does this keep switching on me? 12 equals, then to get my x's over to the right, I would subtract 0.08. So that would give me what, 0.04x, right? Divide both sides by 0.04. I think I get x equals 300. Hey, look at that. Right? So if I take a piece of like cardboard and I want to make it into like an open box, so I'm not going to worry about the top, right? I want to be able to fold up those sides, right? So it makes, I take a piece of paper, I want to fold up the sides to make the sides of the box. So in order to get that to work, you actually got to take part of the corner off. So you cut little little squares. Out of each one of those, I need a piece of paper. Oh, hey, look at this. I even got scissors. Oh, ours is a rectangle, right? Because if I cut off that little rectangle, or that little square, then I can then when it comes to folding it, because I cut it perfectly, you get the little edge. And you throw some tape on there, and then you do it all the way around, and then you got your perfect little box. You guys all knew that, right? So we want to be able to take our little piece of cardboard and turn this into a box. So if we're going to say that we have a 24-inch square that we want to turn into that box, right? So we need to figure out, like when it comes to like how much of this little square do we want to cut off, like because it's going to change the volume. Because if I cut off a little square, right, my box is, I don't know, going to be this size. If I make this square where it's bigger, right? You guys. Didn't know it was going to be Arts and Crafts Day. If I make that one bigger, and then if I cut it perfect, right? Then when you go to fold it, you actually get like a box that's got a taller side, but the base is going to be smaller. So those dimensions are all going to change the volume. So we want to figure out all like the different little sizes in order to cut out that volume. But we need to come up with the general little function, right? So we knew that the side of our square, our piece of cardboard, was going to be 24 inches. So we'd have 24 inches going all the way around this little guy. But we're cutting off those little pieces, and do we know what size we're cutting off? No. So when we don't know something, we can call it our little variable. But we know that we have to cut out little squares, though, perfect little squares. So if I cut 2 inches off of here, I have to cut 2 inches off of here. So we know that they have to be the same. So we know like this little piece would be X, this little piece would be X, right? And that would be true all the way around because we want our box to look better than my box. We want it to be a perfect little box. So we know all those little pieces that we cut off all have to be the same dimension. So they'd all have to be, X's, right? So if we want to find the volume, because we want to know how much it's going to hold, I can't write. Anybody remember what the formula is for volume? That'd be like length times width times height. Remember that little guy? So we need to see if we can figure out our length, our width, and our height for this little box. So we know that we started with 24 inches going all the way across, right? I'm gonna take that out. But from here to here would, I guess I should do the color. From here to here is 24. But we're not using that whole entire 24 when it comes to our box because we cut a little piece off. We cut this little piece off and we cut this little piece off. So to figure out this whole entire side, we had 24 to start with, but then we cut off this little x and this little x. So we actually cut off 2 x's. Right? And then the same thing kind of happened over here, right? We started off with 24 inches, but what did we cut off? We cut off this x, and we cut off that little piece, which was x. So we cut off 2 x's. So now we just got to figure out the height, right? So the height is like how far it came up. So, oh my goodness, I can't believe I'm going to try and draw this. Or somehow you do it like this. And you connect these guys. I don't know. We're just not even going to go there. So when I folded my box up, I folded it on these little seams, right? So when I fold it up, I actually folded it along this line and along this line and along this line and along this line, right? And then all those little pieces flopped up. So my height would only be the x. So to figure out my formula, my length was 24 minus 2x. I'm going to scoot this over. So my length was 24 minus 2x. My width, same thing, 24 minus 2x. And then my height was how much of those flaps I folded up, so I folded up an x. And then just to clean it up a little bit, I could just write it as like 24 minus 2x squared times x. So then now we can figure out what the volume's going to be. So let's say I only wanted to cut off a 1-inch square. Could I figure out the volume? Yeah, I'm just going to plug that into there, right? 24 minus 2 times 1 squared times 1, and I can figure out the volume. What if I cut out 2 squares, or 2-inch squares? Could I figure out what my volume would be if I cut out 2-inch squares? Yeah, same thing, right? 24 minus 2 times 2 squared times 2. And I can do that math and I can figure out, okay? And I can keep going. I can figure out what it is if I cut out a 3-inch. Or I could figure out if I cut out a 4-inch. Right? But eventually you'll run out of room. Right? What do you think what's the size, this little square that I'm cutting out? What's a dimension that I can't cut out? Like if I think of like whole numbers. Could I cut out 10 inches? Could I cut out like a 10? Ooh, I guess it would be like a 10 by 10 and a 10 by 10. I could. Could I cut out a 12 by 12? If I cut out a 12 by 12 and the whole thing's 24 inches long, I wouldn't have a box anymore, would I? Right? So you do have a limit. So that kind of goes back to that whole thing, that domain, right? Like we know that we can't have X values greater than 12 because it will eliminate our box. Right? Sound like fun? So now you got a box to put your phone in. And then your dog ate your phone. See, this is why you had to build the box, because you have a dog. And the dog ate your old phone. So you just got a new phone. So you got to send your old phone back in a box. So we got that, right? So now you're mad at the dog. So now you're going to go to the backyard and you're going to put a fence up in the backyard. So now you need to know how much fencing you need. See, this is how math happens every day, right? So in your backyard, let's say you have, you like asked your brother, right, or your dad, right, hey man, I need some fence. And he's like, well, all I have is 800 feet of fencing. So you have 800 feet of fencing. To enclose, your backyard's a rectangle, right? A rectangular field or area for Fido. Fido gets a rectangle. So again, like I have 800 feet of fencing, so I can make a whole bunch of different dimensions of fences. But we love Fido, so we want to give him the most possible area possible. So off of that 800 foot fencing, we want to figure out, what's going to give him the most. So we have to make this little, rectangular shape. Right? And it could be a whole bunch of different dimensions. If I know that the total is 800, I don't know, I could make, this side 50 feet, and it's a rectangle, so this has got to be 50 feet. So that would be 100 out of my 800, so now I'm down to 700. So that would be like this piece is 350 and this is 350, right? Or you could keep going with a whole bunch of different dimensions, but you don't want to sit there all day and like be figuring all of these out. So you wanted to actually come up with a formula for these. And when it comes to a rectangle, we know that opposite sides are always going to be equal, right? So if we think of the fact that we only have 800 square feet, right? So if we were to split that in half, it would be 400. So like the maximum this could be would be 400 and 400, except for the fact that it wouldn't give us any width, right? We wouldn't have any more fencing for these two sides. So we're going to make our short sides our variable. So we know this has got to be an x and an x. Okay. And when it comes to the length of it, we knew like the maximum could be like 400, although it really couldn't be 400 because that wouldn't give us a rectangle. So we're going to subtract that x off of that. To where, if I said that this was 50 and 50, which is 100, and this would be, 400 minus 50, which would have been my 350, and my 350, which would give me my total of my 800. And if my top is 400 minus x, I know that the bottom's got to be 400 minus x. Everybody remember how to find the area of a rectangle? Length times width, right? So to come up with our little formula, the area is going to be, well, what do we want to put in for our length? 400 minus x, and then do x for our width. Or the other way around, because you're multiplying them, so it doesn't matter which one you put out front. And then you could go through your whole different little dimensions to figure out what one's going to give you the best. All right. So you're sending your old phone back. You got your new phone. Fido's taken care of. Now you're like, let's just do some boring old math. So let's do some numbers. So let's say we wanted to know what the sum of two numbers, the sum of two numbers is, let's say, 66. Sum means what are we going to do? Sum is adding, right? So we're going to add two numbers together that are going to equal 66. And we also want to be able to express the product as a function of x. So we know that when we add the two numbers together, we're going to get 66. But they want us to then write the product, which is multiplying. We want to be able to multiply those two numbers together, but we only want to have the variable x in our little problem. So let's start with this little top piece. Okay. So the sum of two numbers is 66. So what do you want the first number to be? Do we know what the first number is? No. So we're going to call that x, right? And then what are we going to do to x? We're going to add another number to it. And do we know what that other number is? No. And unless it's 33, it's not going to be the same. So we don't know what it is, and it can't be the same. So we're going to say that that's y. And we know that when we add those two together, we get 66. Okay. And then when it says express the products as x, they ultimately want us to write the product would be x times y. But we can't have that as a y. We have to have it as, the only thing they want to see is x. So somehow we got to get rid of this y. We got to make a substitution. So if we go back to our sum, okay, could we solve that for y? Yeah, we just subtract x from both sides, right? So we would have y equals 66 minus x. So now when it comes to writing my product, I can make a substitution. Right? We know that x is going to be x. But we now know that y is 66 minus x. So could we substitute that in for that y? And that would be 66 minus x. So now we express the product, multiplying the two together, with only x's. Whoops. I want a box. Okay. And if they asked us to write the sum now as a product of x, we now could do that, right? You get x plus y equals 66, right? We get our x. We now know that y we can write as 66 minus x equals 66. And we wouldn't want to simplify, because if we simplified it, the x's cancel and you get 66 equals 66, which is true, which is a good way to check it, but. All right. You guys want to try a couple?